Yes, sir.
Okay. So today we are going to start May June 2022 or 22. Okay. So let's start with question number 1. Magnesium has a melting point of 650 degrees Celsius and high electrical conductivity. Okay. Explain these properties of magnesium by referring to its structure and bonding. Okay. So when we talk about the high melting point, we must comment about, the melting point is basically related to or high melting point is basically due to the strong metallic bonds. So we can write that melting point is high as many strong metallic bonds. As magnesium is a metal, so we would refer to a metallic bond. And you all know that metallic bond results in the formation of a giant lattice in which there are metallic bonds throughout the whole structure. And then high electrical conductivity. So we may write that electrical conductivity is high due to delocalized electrons, or you can write free moving electrons which can move throughout the structure. Now, B part. When magnesium is heated in air, magnesium oxide, MgO, is the major product. A smaller amount of magnesium nitride are also made. Okay. Calculate the oxidation number for magnesium and nitrogen species in magnesium nitride to complete table 1.1. So if we look into magnesium nitride, it's Mg3 and 2. We know that the sum of the oxidation numbers must be equal to 0. And if you look at magnesium in the periodic table, you will find it's in period 2. So it's in group 2. So it means there must be a positive charge on a magnesium, right? And there are 3 magnesium atoms with positive 6. So if there is a positive 6 charge on 3 magnesiums, then on 2 nitrogens, there must be a negative 6. That's why it gets 0. And there are 2 nitrogens. So in means that each minus 3 oxidation number. Yes, we always do write for the metal, the oxidation number of a metal if there is a metal from a group 1, group 2, or group 3. See, if you recall, let me show you. We have discussed this in the redox the order by which we place the oxidation numbers. Let me show you.
और सर नाइट्रोजन ग्रुप 15 में
Group 15 में, yes. See, this is the order by which you would place the oxidation numbers on elements in any compound. If there is an element from group 1, group 2, or group 3, then you would put a charge on that, then hydrogen, then the most electronegative one among these, and at last the if there is any other element. Okay. So we'd figure out that magnesium, its oxidation number is positive 2, and the oxidation number is negative 3. Now, what they are asking, identify the type of reaction which takes place between magnesium and nitrogen. Yes, can anybody tell me the reaction? That the reaction is actually taking place between magnesium and nitrogen, and we are getting this magnesium nitride Mg3N2. So to balance the equation, I have to just put 3 over here. Yes, so can anybody figure out which reaction is it?
Redox.
Very good. Because see, there is a 0 oxidation number on magnesium because it's an element right now. In the same way, nitrogen's oxidation number is 0 as well. And we have identified that here the magnesium is +3 and nitrogen is -2. So magnesium oxidation number is increased, so it means it is oxidized, and nitrogen's oxidation number is decreased, so it means it is reduced. So we just write over here that redox, because they ask us to identify, then they ask explain your answer. So we can either write that the oxidation number of magnesium increases, and then you can write oxidation in the bracket, and the oxidation number of nitrogen decreases. So in the bracket, you may write reduction. Is this understandable to everyone? If anyone have any confusion?
No.
Now, if you recall the definition, it is the enthalpy change when one mole of compound. Here, this is very important thing because sometimes the student misplace this compound with a substance. So if instead compound you write a substance, then it would be marked as wrong, because when we say substance, then it can be an element or a compound. So it is restricted to compound, to the formation of a compound only. So it is the enthalpy change when one mole of a compound is formed from its elements under standard conditions. Okay, now next part. When 3.64 gram of magnesium, so it's the mass of magnesium over here, burns in excess nitrogen to form magnesium nitride, 23.05 kilojoules of energy, so it's a Q, is released. Calculate the enthalpy change of formation. Show your working. So if you recall, they have provided you the energy that is released during the reaction. So there have one expression that we discussed is, yes, for what chemical, Virat? Yes, we can write the symbols. But if the examiner say, for example, write the name, then you must write the name. If you identify the substance, so it can be written as a symbols or the formulas or the name, whatever it is. Okay. So to find the enthalpy change, there is a one expression that is enthalpy change is equals to minus Q over number of moles. So this Q is provided over here, right? And for the number of moles, we are provided with the mass of magnesium. So what we do, we divide the mass of magnesium with AR of magnesium. Okay. So first we attempt this thing to find the moles of magnesium. Then we do the enthalpy change. Then we use the enthalpy change expression to find the enthalpy change delta H. Okay. So moles of magnesium would be equal to 3.645 grams divided by its AR. And the AR of magnesium is, if you look in the periodic table, it's 24.1. Can anybody tell me the answer?
सर अगर ये एंडोथर्मिक होता तो फिर आप माइनस के साइन नहीं लगाते ना?
No, we always put a minus sign over here in the expression, because otherwise they have to tell you that the energy is released.
तो सर मतलब
That's why.
दो हम माइनस के साइन लगाएंगे.
Actually, it depends. Here, I got this information that energy is released. So if the energy is released, it means that it's an exothermic reaction, right?
जी सर.
And that's why the enthalpy change of formation must be negative, the answer with the negative value. So that's why I put a negative sign over here. So I get the answer in the negative only because it's a positive. Okay.
Mole 0.151.
Moles are 0.151.
151.
Okay. No, this is the formula for enthalpy change. 1 minute, I will show you. This is mentioned in the notes as well. So we have got the number of moles.
सर डिवाइड बाय 3 करेंगे.
1 minute.
मल्टीप्लाई बाय 1000 करेंगे किलो जूल.
No, because it's in kilojoule. It's already in kilojoule, so there is no need to multiply or divide by 1000. Yes, we would divide by 3 first these moles, because these are the moles of magnesium. Okay. And if you look in the equation, let me write the equation over here, that we have made the equation earlier as well, that 3 moles of magnesium reacting with 1 mole of nitrogen forming magnesium nitride. And we have to find the enthalpy change of formation for magnesium nitride. So it is 3:1. So these are the moles of magnesium nitride would be 0.151 divided by 3. Yes, can anybody tell me the answer, please?
0.05.
0.05 moles of magnesium nitride. Okay. Now we got the moles of magnesium nitride. Now I'm going to use the expression that minus the energy released is 23.05. If I divide it by 0.05, that are the number of moles, I would get the answer kilojoule per mole. Yes, answer please.
461.
I couldn't hear
Sir,
you.
answer is 461.
Minus 461, right? So it's minus 461, and see the unit is not mentioned, so you must mention the unit as well. Is this understandable to everyone? Now next part. Radium is an element found in group 2 of the periodic table that is a crystalline solid at room temperature and conducts electricity. Radium chloride, RaCl2, has a melting point of 900 degrees Celsius and is soluble in water. Predict the lattice structure of RaCl2 based on the properties described. Okay, so we are observing what that the melting point is high and a metal is non-metal is there, so it means it's an ionic, and the ionic lattices are always giant ionic. So we write over here giant ionic lattice. Is this understandable to everyone? Next, draw dot and cross diagram to show the arrangement of outer electrons in radium chloride. So it means we need to show only valence shell electrons. Okay, so radium, if it's in group 2, so here it would become a radium 2 positive ion. So its outermost shell would be vacant, and chloride becomes -1 ion, which means it have a complete octet because chlorine is in group 7. So it have a 7 valence electron and 1 electron. It gained the 1 electron. So I would make a radium ion over here, enclosing, put a 2 positive charge, then chloride ion, where we make 7 electrons with a dot and 1 electron with a cross, as it gained 1 electron, and the other chloride ion on the other side of radium. You must keep this in mind when you are making 2 chloride ions which are of a same charge, so they cannot be drawn together or side by side because they have a same charge, so they would repel each other. So that's why they must be on the opposite side of the positive ions. Again 7 electrons.
सर ये रेडियम का
And one
बेसिकली वो दिखाया हुआ है जो खाली हो चुका है.
Yes. Yes, is this clear to everyone, the dot and cross diagram?
Yes, sir.
Okay. Then solid radium and calcium show similar reactions with H2O, but reaction occur at different rates. Yes, if you look in the periodic table, they both belongs to group 2, right? And from group 2, period 2, period 3, 4, 6. So if you look at the positions in period 2, there is a beryllium. In period 3 of the group 2, there is a magnesium. Then you have a calcium. Then you have a strontium. Then you have a barium. And here you have a radium. So, no, it can't be covalent. Why would it be? Because of a high melting point, and there is a metal and a non-metal, so it must always be an ionic lattice. So here there is a calcium and here there is a radium. So we can say that it is more reactive, right? Because down the group 1 and group 2, the reactivity increases. Okay. Now what they are saying, that separate samples of each containing a single piece of solid radium or calcium are added to equal volume of a cold water. Okay. So it would react more vigorously because its reactivity is quite higher than the calcium. Each sample contains equal number of moles of solid and water is in excess. Okay. Construct an equation for a reaction of radium with the water. So for group 2 metals, that when the group 2 metal react with the water, the general equation would be a metal hydroxide as our product. And as we move down the group, the solubility increases and hydrogen gas. So in this same equation, what I need to do, I need to just replace M with a Ra, that is the symbol of radium. So we would get ROH twice and hydrogen. Is this equation is clear to everyone? As it's not balanced, so I have to put 2 over here. Now the equation is balanced. Okay.
सर हर ग्रुप में डाउन द ग्रुप रिएक्टिविटी बढ़ जाती है ना?
No. In metals, down the group reactivity increases. In non-metals, the down the group reactivity decreases of their elements.
अच्छा जी सही ओके.
Identify which element, radium or calcium, reacts with water at a faster rate. So we already decided that it's a radium which reacts with water at a faster rate. Suggest how the observation of each reaction would differ. So if you look at the equation, if I put the state symbols, it's a solid, it's a liquid. Here we got an aqueous and a gas. So what would be 2 very obvious observation for this reaction?
Hydrogen gas.
So how would you say hydrogen gas? What would be the observation?
Effervescence.
Effervescence or bubbles, right? That is one obvious observation, because with the aqueous solution, a gas is forming. So you are going to observe a bubbles or effervescence, right? That is one obvious observation. What would be the other obvious observation?
White solution.
Sorry?
Color change होगा.
No, it's a group 1, group 2 compound, and group 2 compounds are colorless or white.
तो वो white solution नहीं बनेगा.
It's
Sir, white
aqueous,
solid
right?
disappears.
White solid disappears. Very good, Ubaid. See, it's a solid on the reactant side and there is no solid on the product side. So we can say that solid disappear. So these are the 2 obvious observations that we can easily make by looking at the equation, because there is a solid and that solid is not anymore on the product side, right? And there is a gas forming in the on the product side along with the aqueous solution. So we are going to observe the bubbles. So now they are asking in the next question, suggest how the observations of each reaction would differ. Okay, you have to identify how these observations are actually there is a difference. So can anybody tell me the difference? What it would be?
Sir, rate
तो
different होगा
कैल्शियम
मतलब.
में हाइड्रोजन गैस लाइक बबल्स कम होंगे compared to
Okay, that's good. And yeah, that's good.
मीडियम
and
के
sir
लिए
like जो white like जो solid है वो जल्दी disappear हो जाएगा.
Okay, good. So we can write that. First, we would write that radium reacts at faster rate. First, we would identify the element, right? So radium reacts at faster rate. Then we can write the difference in the observation by means of any one of these observation. Either we can write that solid disappear more quickly, or you can write more bubbles per unit time, because we are talking about rate, right? So more bubbles per unit time observed.
Sir, हम medium reacts more vigorously लिख सकते हैं
Is this
sir
clear to everyone?
than calcium.
Yeah, that is right thing. But see, read this. How could that it is reacting more vigorously is justifying that the difference in observation? So for the difference in observation, you have to either write the observation and then state that it is going to be happening more quickly.
Okay sir.
Suggest why these reactions occur at different rate. And it's of 2 marks, okay? Yes.
Sir, due के the group 2 के elements reactivity increases down the group और radium like calcium से नीचे है.
But how or why?
सर रिएक्टिविटी इसलिए
Sir,
इंक्रीज
क्योंकि
different
atomic
period की वजह से.
size increase होता है तो वो न्यूक्लियस से दूर हो जाता है like outermost electron, तो उसके लिए lose करना आसान होता है. Shielding effect increases.
Okay. But for 2 marks, how you would write?
Sir, atomic size increases. Shielding effect increases. Forces of attraction
Okay,
between the
okay,
nucleus
okay.
and outermost
Just tell me, when the group 2 elements react, what would they do?
lose electron.
Lose electron. Okay, very good. So to lose the electron, do we need any energy? Yes.
Yes.
And what we call that energy?
activation energy.
No, activation energy is the energy that
To
is needed to
overcome
start
the
the reaction.
electrostatic.
I'm just talking about the energy that is needed to remove the electron. Ionization energy, right? So calcium also loses the electron and radium also loses the electron, but the outermost electron in case of radium is are actually further away from the nucleus. That's why its ionization energy would be lower. That's why it loses electron more readily, and that make it radium more reactive, right?
So sir, इसमें हमें ionization energy के terms में answer लिखना है.
Yes, we can write that answer in terms of ionization energy, or otherwise you can write the answer as well that the for the reaction of radium, the activation energy is lower. You can write also that as well instead of referring to the ionization energy.
Okay, sir.
So the first statement would be that, for example, the ionization energy for radium is lower. Is this part is understandable?
Yes.
So for the second mark, I can write that electron loses from radium more readily or beside this, yeah, you can consider atomic radius as well. There's no harm in discussing. You can write about atomic radius as well. So we can write that the activation energy for radium, instead of these two, we can write in this way, of radium is lower than calcium. And when we referred activation energy, then our next point would be the explanation of this activation energy, which is that more particles have energy equal to or greater than activation energy. Hence, frequency of successful collisions increases. Or instead these two, you can talk about the atomic structure, that as the radium have a bigger size, so the valence electron is further away from the nucleus, so it can be easily released, or it can release the electron more quickly. Is this understandable? Yes.
Yes.
Okay. Now,
तो shielding effect के बारे में भी लिख सकते हैं.
yes, when we talking about the the atomic structure, then you can refer to shielding effect as well. The more shielding effect in the radium, so there would be lower attraction between the less attraction between the nucleus and the valence electron, so the valence electron would release more readily or more quickly in radium. Okay. Now part 4, one of the solution is cloudy when the reaction has finished. Okay. So if you recall the trend that when we move down this, so it means when I compare, when calcium reacts with the water, we would get calcium hydroxide, and when radium reacts with water, we would get radium hydroxide. So this radium hydroxide is actually more soluble, which means that this cloudy thing is calcium hydroxide. Is this understandable?
Sir, हमें कैसे पता? इसमें तो one of the solutions लिखा हुआ है ना, तो सर वो सल्फेट भी हो सकता है ना?
No, we are continuing. See, here the examiner told you that radium and calcium react with the water at a faster rate. And here, if you see, we are doing the part C. In part C, there is a reaction between water with the calcium and water with the radium. So in one reaction, we are getting radium hydroxide, and in the other reaction, we are getting calcium hydroxide.
Okay, sir.
So at the end of each reaction, universal indicator is added to each reaction mixture. Suggest pH values of the solutions made in both reaction. Explain your answer. Okay. Now, which one had a greater pH? calcium hydroxide or radium hydroxide?
Radium.
Its pH is relatively larger, relatively greater, and its pH is relatively lower. But what is common between these? That the pH of any one of these would be greater than 7 because both are basic, right?
Yes.
So they are asking you to suggest the pH values of the solutions made in both the reactions. So first suggestion is that the pH value of both the solution must be greater than 7. Is this part is understandable to everyone? And then the second point, we can say that the pH value of the solution having radium hydroxide is greater than the other solution. Is this understandable, the second point?
Sir, वो more soluble है इसलिए.
Yes, if it's some, yes, it's a more soluble, so it means more hydroxide ions in the solution, so the pH would be more high.
और reactivity की वजह से वो ज़्यादा soluble है.
No, it's reactivity and the solubility are two different things.
तो radium क्यों ज़्यादा soluble है? कैसे ये कैसे पता चल रहा है?
This is actually, you know, from the trend that we discussed in group 2, that when we move down the group, the solubility of hydroxide increases.
सही है.
And the question that you asked, that it's more reactive, so it's more soluble. There is no link between the solubility and the reactivity, because the other trend about the group 2 sulfate suggests us that when we move down the group, the solubility of group 2 decreases, group 2 sulfates decreases. So if in the reaction, for example, if we are doing the two reactions, one of calcium and one of radium, in both the reactions we are getting calcium sulfate and the radium sulfate, then in that case radium sulfate would be less soluble, right?
Yes.
But the reactivity of radium is still higher, so there is no link between the solubility and the reactivity. Okay.
Okay, sir. और सर ये ज़्यादा cloudy का भी कैसे पता चला?
Can you repeat your question, please?
आपने जो cloudy वाले उसके नीचे calcium hydroxide लिखा हुआ है ना?
Yes.
आपने जो ज़्यादा cloudy वाले उसमें आपने calcium hydroxide लिखा है, तो वो भी कैसे?
If it's a cloudy, so it means there must be a solid particles which actually doesn't get dissolved. That's why the solution becomes cloudy, right?
अच्छा, ओके, सही समझ.
Okay, now D part. A sample of aqueous calcium halide, CaX2. So here it can be iodide, bromide, chloride normally. Contains either chloride, bromide, iodide. Okay, they have mentioned, sorry. Complete the table 2.1 to describe two-step processes that could be used to identify the halide ion present. Yes, can anybody know that test? Yes, I think you all have did in your paper 3 as well. Yes, Virat, very good. Silver nitrate. So the method one would be adding a aqueous silver nitrate in all of these solutions. So what would happen?
सर
On
क्लोराइड
adding
में
aqueous
व्हाइट
silver.
होगा, ब्रोमीन में
Yes,
ऑफ
very
व्हाइट
good.
और क्लोरीन में येलो.
Here we are going to get white precipitates. Which color you have suggested for Sana for calcium bromide?
ऑफ व्हाइट.
Okay. But the more preferable color is cream precipitate. You may write cream precipitate instead of white. Okay.
ओके सर.
In case of iodide, we will get
Yellow.
yellow precipitates. Then the second method that we continue, that in these precipitates,
एडिशन ऑफ
what we do,
अमोनिया.
we add aqueous ammonia.
सर इसमें भी दो होते हैं, एक एक्वस होता है, दूसरा कॉन्सेंट्रेटेड होता है, तो
नहीं,
हम
both are aqueous. Both are aqueous. One is concentrated and one is dilute. So you can use diluted aqueous ammonia. In this case, for the white precipitates of chloride, these precipitates dissolves.
सर ब्रोमीन में डिसॉल्व हो जाते हैं ना, और आयोडीन नहीं होते हैं.
To give colorless solution. So how you can differentiate between bromide and chloride?
सर ब्रोमाइड भी डिसॉल्व हो जाते हैं और आयोडाइड नहीं होते हैं.
Partially dissolved.
Yes, partially dissolve होते हैं. Precipitate dissolves partially in bromide.
सर पार्शियली लिखना जरूरी है.
Yes. Because all of the precipitates doesn't dissolve. Only some of the precipitates out of the total precipitate dissolves. Okay.
So your observations group 2 के notes.
It's in group 7. Group 17.
अच्छा सही है.
And in this case of yellow precipitates remains insoluble. Now we are going to start question number 3. 0.025 mole of hydrogen iodide gas is added to a closed vessel and left to reach dynamic equilibrium. The total pressure of the vessel is 100 kilopascal. Okay. What is meant by the term dynamic equilibrium? And it's of 2 marks. So we have to state 2 things. So what one can be? Rate of
forward reaction is equal to rate of backward reaction. It is a closed system.
Okay. Rate of forward reaction and backward reaction are equal. So this statement will get you 1 mark. Then the other can be, there is no change in concentration of reactants and products. So for 2 marks, you have to write the 2 features of the dynamic equilibrium. Is this clear? Yes. Describe one difference in the initial appearance of the reaction mixture compared to the mixture at equilibrium. Yes. What would be the initial appearance and what would be the appearance at the mix equilibrium? In product, we are getting iodine as a gas. So what is the color of iodine? What is the color of the vapors of iodine? Aren't they purple vapors? So, and it's a compound of group 7. So compounds of group 7 are colorless unless they have a transition metal. So the color change would be colorless to purple. Is this clear to everyone? Yes?
Yes.
Okay. Now we have a KP, then it's equation. Okay. So I think we will keeping the class over here. Probably let's see tomorrow or the day after tomorrow, we will continue the past paper from here. Okay.
Hello, sir.
Okay. Take care, everyone. Allah Hafiz.